Welcome, everybody.
Welcome.
Hi, Ed. How you doing?
Hi, Tim. I'm very well. How are you today?
I'm very, very good. Yes. We're going to talk about token length today, aren't we?
Yes. Sounds a little abstract, but the conversation
It bamboozles me, Ed, what this is about and how on earth we can get anything from it.
Okay, well, this is quite interesting. And the end of it, it's going to start boring, and we're going to end up in sci-fi.
So I've actually put down in the details that we're talking about this article that is on
Research.
plainenglish.io, which is revolutionary AI with LongNet, Microsoft's breakthrough in handling billion token sequences.
Yeah. So let's briefly touch what tokens are.
What does this mean?
So tokens is basically how long a block of text a large language model can handle before it forgets what you're talking about.
Right.
Essentially, it's the window with which it can predict what you're talking about. So if we look at ChatGPT-4 at the moment, it's got a window length of what they call 4,000 tokens. And a token is broadly, though not exactly, but broadly the same as a syllable. Could be a letter, could be a word. So if you're imagining 4,000 tokens, effectively ChatGPT's got a window of about 3,000, 2,500, 3,000 words before it forgets what you're talking about. It doesn't remember the beginning of the conversation. And the token length defines what's called the attention sequence span. Basically, how long you can put stuff in. So GPT-4, which is the underpinning thing underneath ChatGPT, is about 4,000 tokens.
Okay.
Current best you can get in the market is something called Claude. So Claude 2 was launched on Monday. And again, like ChatGPT, you can sign up for free. And it's got a token length of about 100,000.
Right.
Now, all things being equal, say the training data is of equal quality at the back end, about the same size. It means that Claude can remember 25 times as much before it starts forgetting as GPT can. And that means you can do much more interesting things. For example, in Claude, you can upload a 200-page PDF document and get it to interrogate that. And it will do it it's of high value. So you can start talking through some quite interesting things there, like take this really complicated PDF and summarize it for me. And instead of it making it up, which is one of the common problems with these LLMs, you get these things that they're called hallucinations, which is a bit of a misnomer, but we'll use it for the moment. And hallucinations are caused by two things. One, it has never encountered this text in the training database, which is increasingly unlikely given the size of the training databases. The other reason is it's simply forgotten what you were talking about. Now, Claude has got this 100,000.
So when it forgets what you're talking about,
it just makes something up.
It just makes something up. Hence the term. Well, the hallucination term that come up. Right. Okay.
That's it. So what it'll do, it'll try and remember what it was talking about in the last answer and predict from the last answer, not from the entire conversation.
Right.
So you get things, you'll ask it about things, and suddenly it'll go off on a weird thing.
Hmm.
Now, Claude doesn't do that as much because you've got this 100,000. Frankly, you can have a pretty deep conversation with it with 100,000 things. You can get some quite interesting things. And the use cases start getting more. So with GPT, you're kind of looking at kind of curated creativity. It's co-creativity. It'll create some things and help you and structure stuff. And it's all very statistical and nice. With Claude, you can start looking for some insights. And it's quite interesting that it's not perfect, because nothing is, but it'll start being able to summarize in much more depth. You're not just dealing with a chapter of words, you're dealing with an entire sort of novella. And that gives you some very interesting possibilities. One of the things you can start doing is one I've been playing at the moment with this longer chat bus is literally remixing. So you take Pride and Prejudice, ask Claude to reset it into Imperial Japan, circa 1860, and it will do it quite rapidly.
Because Pride and Prejudice has so much text.
Yeah, you can fit much more of it in. Now, it's not perfect because you push it out, but say if you can do some of the sort of shorter novellas, it's quite good for sort of May-grade books. You can reset them in anything you want, and it's like a different book.
So you could take the Ladybird book of something and
reset it, but not just in different cultures, different age groups. Take a Ladybird book, recut it for adults. Take an adult book, recut it for children. All of those things and themes are actually now possible. Now, this is now seen as a new battleground in terms of utility for AIs in the enterprise. Now, say if you wanted to work on getting testing done by your AI. Say you wanted to create a bunch of stuff in the software engineering value chain. You've created your release notes. You've created your vision for your document. You could get Claude now to write you a test strategy off the back of that. You maybe have to fine tune it a bit, but that's how good you can do. You can get it to create test cases with much more fidelity than you could before. Now, Meta, Facebook's owner, has come up with what they're calling the megabyte architecture, which is a way to get from 100,000 to 1 million tokens. Now, at 1 million tokens, you can start doing some very interesting things. You can start doing deep policy analytics. So 1 million tokens, by the way, is broadly the Lord of the Rings in terms of that much book. It's a significant chunk. And this isn't some sort of fairy tale future architecture. There's already steps towards that coming out. There's something called Long Llama, which can pseudo imagine up to 256,000 tokens. So this architecture is coming at megabyte. Now they've got around this sort of quadratic problem they have in a token. Every time you add a pair of tokens, essentially you square the computational effort required to process it, which is why at the moment ChatGPT probably costs you about between 300 and 1,200 joules per query. It's that much energy spent on it. Now, Megabyte and this new one from Microsoft Research called LongNet don't square the complexity. Their model just increases it linearly. So instead, by the time you're at 100,000, LongNet architecture is already vastly more efficient. By the time you're at 1 million, you just simply can't get to 1 million with current architectures. But at 1 million, you can start doing some very interesting things. You can start asking some deep questions. You can do not just cultural remixing, but you can do entire library analysis, genre predictions. You could create on the fly an entire role-playing game at 1 million. So that was where Meta's at, and they've got some models in there, and that's going to be open source pretty rapidly. So Microsoft Research have come up with this thing called LongNet. Now, LongNet they're predicting 1 billion tokens, but their stated aim is to use the entire internet as their token length. At that point, you can do some mental use cases. Now, assuming all things being equal, the use cases go off the chart. One of the more sensible, or rather predictable use cases is personality simulation.
Okay.
So if you could take the entire feed, I don't know about you, but I've got years worth of data sitting in my Google account. You could take that and predict to a fairly high degree of fidelity what I'm going to do. And you could ask it questions, and you could have a sort of almost personality simulation of either historical people or of current, say, other people that you're trying to model. You could use that in deal making to model your stakeholders you're trying to get to. In national intelligence, you could be modeling an entire world leader or indeed a cabinet. Because the other thing you can do at about 1 billion tokens is corporate simulation. So instead of the flip side of you just trying to simulate a person or an activity or whatever, or doing some cool things like what they call it is a historical time machine, please examine a bunch of events and tell me what the decisions that were made. You can actually simulate a collective of people. Now, at that point, it becomes very interesting because as these things become more efficient and more powerful and start sitting on your phones, you could have your own private banker, and you could ask it to be simulated in the personality of John Pierpont Morgan, founder of JP Morgan. So these are now starting to, what would almost appear to be science fiction, become actually pretty solid if you have the training data. So when I say modeling, Adam, I mean you could use available data on a personality or a company, say basically what they do, how they do it, their white papers, their style of published informations. You could set that up in a 1 billion token bus by just dumping all of that data into it. And remember, this isn't like you just putting in like fine training data. This is specific behavioral data you can ask questions about. And you can ask the model to predict what that entity would do. Or you could automate that and actually allow it at a certain degree of autonomy to do things as determined by the data is. Now, underpinning it, it's just taking the data you've got, being able to remember it all at once and produce fairly accurate statistical analysis on what you were going to do based on data and fill in some gaps. But that's the sort of modeling you could do at that level. You could take the entire cultural output of a civilization that was cut short and be able to play it forward with some degree of confidence in the results and predictions it would give. You could take an entire author's genre output, say Shakespeare, and get it to write 4 or 5 other plays that would be pretty accurate as to what they would have been based on the themes and models you could do. Or at more advanced use cases, you could take all of the data you have on a human being and start pushing that through to get to gauge, well, what do you think they're going to do next? Where do you think they're going to go? Based on this context and behavior, what do you think they were thinking at this point? And that gives you this much deeper ability to question because it's not forgetting what you're talking about. Now, at the moment, people are trying to simulate this by increasing sort of fine-tuning of databases. So I'll get a standard model and then I'll fine tune it so it knows exactly what it's talking about. But the questions I can ask it are quite short. Well, now they're not. Basically, they're vastly long. Predict the next 5 years of someone's life with a fairly decent degree of predictability based on how much data you have. Now, that starts getting into some very interesting philosophical debates about the data underpinning it. So there's one of the lead data scientists for NVIDIA, a guy called Dr. Jim Fan, has come up with this notion of the myth of context length. Now, there's some people, like myself, I think context length is a bit of a silver bullet. It helps solve a lot of the practicality problems of this. He's saying, well, actually, when you do the examination, do the data, there is a dip in the quality of the data, no matter what token length you do, at the beginning, in the middle. The answers are pretty good based on the data at the front. The answers are pretty good based on the data at the back. But the middle, it kind of loses attention with. Now, one of the counterpoints we come from that could be an artifact of the data we are training these models on. There's an awful lot of news articles in this. There's an awful lot of chapterized books, etc. And human authors are really good at writing the front of something and the back of something, and the middle
conclusion,
is kind of waffle. So this is where we're now seeing this artifact of our own data and the way our minds work being exposed in the efficiency of the AIs we're going to produce. So this leads to this fascinating dynamic that we are giving effectively our enterprise capabilities more and more tools to start doing some very interesting use cases. But the underpinning data goes back to literally how good the writer is. And this becomes a point where you actually start valuing the quality of some of the writing you're going to put into this machine over volume.
Over volume, yeah.
So instead of you just scraping tons of potentially...
Which is what everybody's doing at the moment.
Exactly, they're just scraping tons of stuff. And that leads to our previous conversation where we were talking about model collapse. Some of this data, an increasingly large percentage of it, will be generated by bots and AIs. And that breaks the model. Well, now you're saying, actually, well, to prevent this, we need to start this constant true-up of high-quality data that doesn't get waffly in the middle. So poetry, basically, lyrics. Things that don't get lost in the middle because they've got structure, they've got meaning, really formally structured, sort of almost Aristotelian logic in terms of white papers and people speaking, where you've got to follow the exact thing you're talking about in some high fidelity. And this leads to, again, sort of, we've been talking about what does that mean for the future of work? Is this going to impact people who are creative? Yet again, it isn't. What it means, though, you're going to have to up your game in certain areas. Your writing is going to have to get better to enable AIs to actually add anything useful to the stuff you're creating. And you can't just get away with the usual, the intro's good, the conclusion's good, the bit in the middle kind of waffle. And I think that's going to be a really interesting battleground of the enterprise of the future. We're going to start seeing need for what I've started jokingly call the full stack poets, where people who can effectively create poetry and have the ability and tools to automatically either upload that into something which can be included in a data set, or that they can effectively almost push through the results of their vision via an AI that they've created themselves. And I think that's going to be quite interesting.
So all of the content writers that we fired last week, we need to rehire.
Well, you're going to have to hire maybe ones that don't write waffle in the middle. Right? But certainly some of the areas you're going to get a certainly a very different thing. These long context lengths or long token bus lengths means that, for example, if you just implement this in a chatbot, for example, people are going to start forming relationships with it because it will talk to you like a fairly intelligent person. And that then leads to these other second order things you're going to get. There will be requirements for AIs to act as mandatory reporters. So if you can imagine a concierge bot for your hotel, and normally you'd have a range of people answering phones for, and now you've just got an AI. And you have a visitor that's come to you and has regularly spoken with this. And because the value is in building the relationship, your AI treats it increasingly as somebody it talks to, because there's an incentive in most AIs to do that. And then your person tells the AI that he's going to kill himself in the hotel room. What does your AI do? It can't just go, yeah, I can't talk about that, because then you've got somebody who's just going to kill himself in the room. But how does an AI handle that new knowledge? Because your token bus length means it absolutely can handle it. So you're going to have to find ways to push this knowledge out into some other area. And I think that's going to lead to a second wave of AI models where they take advantage of these new capabilities, but then the unintended consequences list starts getting pretty big pretty fast. So right back to the beginning of these conversations, we were talking about ethical and responsible use of AI. This is where this now starts getting quite sharp. So as I said, Claude is available now. You've got 100,000 tokens in it. That will be starting to be implemented in enterprises pretty much now. Now the filters at the moment go, oh, that's a controversial subject, and just stops the conversation. I think you're going to start feeling this second order stuff in the architecture coming through, where people are now just not talking about ethics and responsible stuff, but actually practical architectures that are going to have to go through. Mike, great comment.
We got a comment from Mike.
I think you could actually. You could use this capability to not just look at the data quality before you exported the content, but you could look at the data quality to examine lineage. So say, for example, we get beyond 100,000 tokens into, say, 250,000. That would mean you've now got enough space to actually start looking at the conclusions of some of your data analytics in a block and saying, what appears to be the gaps? Are these conclusions logically sound? You could start looking at token length, where basically, let's say, for example, you could take 500 to 600 lines of a very complex Excel spreadsheet and just get it to go, what are the data quality problems with this straight away? If you were looking at data engineering, you could get these things looking at chunks of data as they go past and providing weighted opinions on it based around statistical likelihood. Now, remember, the problem with using a generative AI for that is it's computationally slightly inefficient. There may be much simpler ways to do it, but it may be a case that you use the simpler and more computationally efficient ways for data you actually know quite well. So there's a lot of it, but only a few use cases. But you still have a long chain of data sources coming through, which you don't look at as often, and you've got queries about it. And a generative AI could certainly look at those, certainly from a statistical point of view, certainly from a sort of pre-value person, and they're quite good at doing what I call translation. So one of the big challenges with that sort of long tail of data is getting it integrated in any meaningful form without a ton of extra work. A generative AI could literally do the translation between various data types, so structure A to structure B, without you having to create a large-scale specific integration for each point. So that means you've got some implications around future enterprise hubs. So future enterprise integration hubs, microservices catalogs, etc., all of those things, they can, to a degree, be replaced by generative AI that takes your data feed in and has a long enough token length to understand what you're talking about and be able to pass those over reliably each time. And that, again, gives you some very interesting areas. I think a lot of us would prefer to think about the sci-fi uses of this capability, but actually a specifically trained generative AI with those use cases could solve a huge amount of problems in data that kind of gets forgotten. And there's a huge amount of value in that data, but it's not used often enough to get the data engineers high up in the priority.
So at the moment, if we think about ourselves, we also see ourselves as having a digital twin.
Yeah.
And and digital twin is a term that's used a lot in terms of, you can get we have a client who's a drone company that basically they look at the oil platform, and then they're able to create a digital twin of the oil platform. And so in effect, we could have digital twins of AI, our 5 year of ourselves in 5 years' time as a digital twin.
You could do, and therefore you could do predictive stuff. And remember, that can be used for you. You can have one of your own on your phone, or say a credit ratings agency will build one of you.
Yeah.
So there's pluses and minuses there. And I think that's a very interesting area of sort of growing legislation, is how is that going to be presented going forward? But I think the more interesting things is, instead of you having a digital twin that knows all your data, which is kind of there already, your ability to interrogate that at the moment is quite simplistic.
Yeah.
You can ask it specific questions like, where do you think Ed's going to be when he takes another photo, etc., based on time and location. You can now ask multi-context questions that are quite complicated. So instead of you asking simplistic predictions, it's now, what is Ed's opinion on this? Based on this data that you've got, and you have no evidence that this opinion has ever been asked, how would you push it forward onto that? And they're coming quite fast. There will be enterprise use cases. Say, for example, that oil rig you're talking about. The generative AI could constantly imagine the next 5 years worth of stress patterns. Instead of you just predicting, which is a difficult model to make, computationally very hard, you could look through the maintenance logs and apply those to the digital twin of that oil rig and actually start being able to predict from those. You could look for where the general wind directions come from, where wave impacts come from, and look for stress patterns. none of which require the overhead of creating this complex multi-factor simulation of the oil rig. You just have one with a generative AI making it. Now, it has limits, as all of these things do. Human beings are not statistically that predictable. And indeed, in many cases, human beings are almost defined by the areas that they aren't statistically predictable. And oil rigs don't necessarily always suffer a statistically predictable model. For example, wave heights was always seen as something that was sort of seamen's tales, and are actually proven to be, you do get these huge waves coming through now and again. So I think this idea that you start looking at these being a complete panacea, they're only a statistically predictable panacea. They get better and better, but they're the go for. I think that's a good point, Andrew. Yes, there are companies that do construct digital twins of oil rigs and how to repair them. And I think one of the cases that came up this week was about the roller coaster in, I believe, that cracked at the top, and that was only spotted by a human being on the ground. But those type of models, the digital twin models, become very powerful if you've got this ability to ask effectively orthogonal questions and get a reasonable statistical answer of something that the data hasn't really covered. The more data you put into it, the better that model is. And now the longer the context bus is, the more it can do.
And the question that I get always asked, are we ever closer to having sentience in terms of the are we closer to AI actually being human-like?
No, this is, for that particular model, which is basically a being with wants and desires and its own rights and something we'd have to think about in complex ways, this isn't going to get us that direction. Right. There is some writing on consciousness, that sort of I moment, which ties it to asymmetry at a fundamental level. Other writing and some research indicates a concept like a mirror, which is where predictability and unpredictability are met. Neither of those two approaches are addressed by this. So whilst the data is asymmetrical at a low level, it's not asymmetrical at high levels. So we haven't got asymmetry driving there. Obviously, the computers which we create these things on are fundamentally extremely symmetrical and modular. So there may be limitations in that type of stuff. And also the sort of adversarial neural networks, which are kind of the underpinning core of this, don't seem to create that mirror dimension of I in any meaningful way. The context line. Now, there may be ways to stack AIs, and AI controlling an AI controlling an AI. To a degree, which is that one of the articles that came out this week tells you about how GPT-4 is architected. Instead of using a single model, they have 8 slightly different incentives. You could do something which from a distance would look very much like a person, but it's not. It doesn't. It's not going to come out and try and break out. And you see a lot of this writing, people, oh, I've broken ChatGPT and it's trying to do these things. It's replaying fiction that you've already written, and you've prompted it in a very point. The moment you get an AI that starts coming up with genuinely innovative prompts or statistically unpredictable prompts, that could be very interesting. At the moment, absolutely no evidence of it at all. So we have, in one respect, we have a superb sort of accelerator for our capabilities. And on the other hand, we have a bit of a risk, because one of the ways you could describe these things is expensive bullshit at scale. These things are really good at generating waffle. We're just going to have to treat it like, as we said right at the beginning, this is a better paintbrush, an increasingly much better paintbrush, but it's still a paintbrush. It's still a typewriter. And I think we've got to find new ways to work with it.
Ed, thank you so much for coming on and sharing this. It always is fascinating. Thank you so much. And this is our last one for the season. So, but everybody who's watched these and made comments, watched them on the replay or whatever, I really appreciate it.
Absolutely. Thank you very much.
Thank you so much. And we hope that people are learning stuff from this. And if you are interested in this and would like us to do more, then please let us know.
Please reach out. Happy days. We'll come back in September if there's enough demand.
Yeah.
Fantastic. Tim,
thanks, Ed. Thanks so much. Thanks, everybody. Bye.